Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 6, Chemical Foundations, Part 6. We're going to be discussing temperature as well as density in today's video. Pause here. So before we get into temperature conversions, we're going to define temperature, which is just a measure of the average kinetic energy in a sample. So on average, things are moving faster when things are at higher temperatures and slower when things are at lower temperatures. There are 3 main units that we use: degrees Celsius and degrees Fahrenheit, both of which you're likely already familiar with, as well as kelvins. We do not use degrees for kelvins because Kelvin is what's on an absolute scale, which means that you can't go lower than 0, or it's a scalar quantity if you're familiar with that word. So that is why we don't use degrees for Kelvin. These equations right here do not need to be memorized. I'll give these to you. You just need to be able to apply them and be able to pay attention to significant figures. Pause here. I'll work through this, but if you feel comfortable, feel free to go ahead and work through it on your own. Right, so 298 is most precise digit is the ones place. So when I round this, I'm going to round my measurement also to the ones place. So I'm going to end up with 25 degrees Celsius. So then when I go to do degrees Fahrenheit, I'm also going to end up having to consider those significant figures. So I end up with 77 degrees Fahrenheit. So you do have both multiplication and addition going on in the TF one. So you might want to do that in 2 steps to make sure you get the significant figures correct. Pause here. So there's 2 different ways you could go about doing this. I'm going to just walk through one, but you'll get the same answer either way. So you could take either one of these 2 equations, the TF or the TC one. It doesn't matter which one you pick. And then all you do is when Fahrenheit temperature and Celsius temperature are equal to one another, then these values will be the same. So I'm just going to call them T. And then I'm going to solve this like a normal algebraic equation. So a negative 40 degrees Celsius is actually the same temperature as negative 40 degrees Fahrenheit. It's also good trivia knowledge. Pause here. So I'm sure that you've heard about density before, just mass over volume. It's usually measured in grams per milliliter, grams per cubic centimeter. Sometimes you'll see it in grams per liter, especially when we're talking about gases. But we can actually treat density as a unit factor in calculations, such that we don't need to have multiple different steps going on, and to make things less. This just makes things less complicated if we can treat it as a unit factor. We'll take a look at an example with that. Pause here. Right, I will work through this, but again, feel free to move ahead if you're feeling pretty confident on it. So I've got 15.2 grams. So I could take that 1.492 grams per milliliter, and I could put milliliters up top, and then I could do 1.492 grams on bottom. Grams cancel with grams. I'm going to round to 3 significant figures. So I get 10.2 milliliters. You could do algebra for this, and I'm not going to stop you from doing that, but when you get to things that have multiple steps, then it becomes easier to do dimensional analysis. This time I went grams up top. I'm going to round to 2 significant figures here. So for this one, I'm going to convert it to grams before I use the density. I'm going to round this to 2 decimal places, or not decimal places, 2 significant figures. And that bar is over the 0 that's right next to the 8 to show that it is significant. Thank you so much for watching and have a great night.